biophysics professor brought up the concept of negative temperature the other day, and this is the second time a professor has brought this up in class. Which is odd considering the first time I heard about it was from a material science professor, which actually means the subject is very interdisciplinary.
Like us.
Like us. So naturally, I just had to check it out. But first, a bit on physics. I wrote this whole Facebook note on physics the other day after I took the physics GRE, and I liked part of it so much that I wanted to make an entire video about it. But then, in my physics class the other day, my dumb physics professor decided to throw us this negative temperature curveball. And after buying his arguments, I just can't. You see, you're taught in school that nothing can go to absolute zero, 0 Kelvin. You're taught that energy and temperature are correlated in some way, and absolute zero is when the system has no energy whatsoever. All the atoms are frozen. And you just don't think about having less energy than that, because how can you have less energy than not moving? But you can. Well, you actually can't, but there is such a thing as negative temperature. Roll with me on this. No questions until the very end. So, if temperature is fundamentally linked to energy, then how are we measuring that energy? We need a thermometer. The higher the mercury in the thermometer is, the more energy the thermometer has, and therefore the more energy the system the thermometer is in direct contact with has. Or in other words, the thermometer has gained energy from the system or lost energy to the system. And it's true, the thermometer can never lose all its energy and go to absolute zero. But is there a system in which no matter how much energy the system has already given to the thermometer, it can always give the thermometer more? And in fact, the system wants to give more energy to the thermometer. A system with so much energy that when it comes into contact with any positive temperature system, it will always give that system some energy. These systems are negative temperature systems in physics. Now, this might seem like a math trick, sort of like infinity, but physicists don't like infinity, and so we wrapped our number line around. But it's more of a mathematical accident. When I said temperature correlated with energy, you might have envisioned more of a linear scale. After all, wouldn't that be nice? But you see, temperature and energy are actually related in this fashion. Here, the x-axis is temperature, and the y-axis, beta, is the energy term. Beta is actually an energy difference. You see, the beta of a system is actually related to how much energy the system will put in or take away from a particle that is put into the system. Since energies are all relative, let's start the initial energy at beta equals 0. So down here at negative betas and positive temperatures, the particle tends to lose energy to the system, which is what we see in everyday life. Take a ball, drop it in some water, and the ball will lose energy to the water. However, up here, the particle will tend to gain energy from the system. These negative temperature systems want to give away their energy, and in fact, a particle will always come out with a higher energy than its initial energy. This is why negative temperatures are hot, and we don't see these systems in everyday life, but they can be created in labs. And if you didn't understand that, well, don't worry, neither do I. But that's kind of all physics is about, right? So I've actually been going to a lot of the physics talks hosted by the physics department, and let's face it, most of these talks go way over my head. But it's very great watching my physics professors, the people I look up to, interacting with these speakers. And quite honestly, I feel like the talks that these speakers are giving turn my physics professor's notion of the world on their heads. So honestly, I guess I'm not that far behind. If it was easy and trivial, nobody would like physics. In physics, really, fun and hard are synonyms. Honestly, for me, my best moments are thinking that something is weird, but then learning more about the weird thing and realizing that what I thought was weird would be weird if it wasn't true. Looking into physics grad schools these past couple of months have made me realize that I can actually make this fascination I have with physics into a career. This might be a shout into the void, but if you know anybody that's in a physics department or an applied physics department of some sort, let them know there's a random girl on YouTube that wants to do stuff in physics. Cool, cool. You know, past Alice somehow got to work with this random YouTuber with 5 million subscribers, and I kinda genuinely do believe in his degrees of separation thing, so I'm pretty sure I have connections that I don't know about, you know? Okay, well, with that said, see you guys next week. Probably with a video about Veritasium, so cool. I'm being so productive with coming up with these video ideas, you know, a week in advance, but I'm still uploading on Sundays. Well, whoops, bye. This topic is... Why'd you have to mess up, Alice? I don't want to stand up.